NASA has announced the selection of the first science instruments that Artemis III astronauts will deploy near the lunar South Pole. In the next chapter of space exploration, NASA's Artemis program is set to study the Moon like never before. The missions will also lay the groundwork for future human expeditions to Mars. Artemis III, the pinnacle of this endeavor, will see astronauts return to the lunar soil for the first time in over half a century. The U.S. Space Agency carefully selected these cutting-edge scientific tools to help solve the mysteries of the Moon's surface and interiors. Artemis marks a bold new era of exploration, where human presence amplifies scientific discovery. With these innovative instruments stationed on the Moon's surface, we're embarking on a transformative journey that will kickstart the ability to conduct human-machine teaming, an entirely new way of doing science. These three deployed instruments were chosen to begin scientific investigations that will address key Moon-to-Mars science objectives, Melroy added. Instruments will look into various aspects of lunar surface. The first instrument unveiled by NASA is the Lunar Environment Monitoring Station, LEMS. This small seismometer suite will continuously measure ground motion from moonquakes. Mehdi Benna of the University of Maryland leads the LEMS development team. Moreover, this autonomous instrument will provide insights into the structure of the Moon's crust and mantle. This combination of data might offer key details about the formation and evolution of the Earth's natural satellite. The instrument will gather scientific data for a period ranging from 3 months to 2 years. LEMS, on the other hand, may become a key station in a future global lunar geophysical network. Next up is LEAF, the lunar effects on agricultural flora. This instrument has been particularly designed to study how plants grow in the lunar environment for human use. This first-of-kind experiment will track plant photosynthesis, growth, and systemic stress responses under the influence of space radiation and partial gravity. Notably, the valuable lunar environmental parameters gathered by LEAF will be crucial for future human nourishment and life support systems. LEAF development is conducted by Christine Escobar of Space Lab Technologies, LLC, in Boulder, Colorado. Artemis III launch expected in 2026. The last instrument is the Lunar Dielectric Analyzer, LDA. This device will assess the capacity of the Moon's regolith to create an electric field. Interestingly, this will help astronauts look for lunar volatiles like ice. Other science goals set for LDA include gathering vital data on the structure of the Moon's subsurface and tracking variations in dielectric characteristics induced by the Sun's changing angle as the Moon spins. Moreover, the instrument will hunt for possible frost formation or ice deposits, which are vital for sustaining future lunar exploration. LDA is an effort of international collaboration. The development is led by Hideaki Miyamoto of the University of Tokyo and supported by JAXA, Japan Aerospace Exploration Agency. These three scientific instruments will be our first opportunity since Apollo to leverage the unique capabilities of human explorers to conduct transformative lunar science. These payloads mark our first steps toward implementing the recommendations for the high-priority science outlined in the Artemis III Science Definition Team report.